Okay friends, in this module and the next module we are going to look at something called runtime type information. It is a system which helps C++ programmer to determine the type of object at runtime, especially when you are dealing with something called polymorphic object. The polymorphic object example we have already seen, the shape class and the other classes that we have seen in the previous module basically are known as polymorphic objects, which can be pointed to by a base class pointer and can be manipulated at runtime. Okay. So, whenever we would like to deal with them, sometimes we would like to know the type of the object that we are pointing to and like to take decision of about that thing. So, RTTI is all about doing that, and we will be discussing about that in these two modules. So, we will begin with this thing, as I said, runtime type information or RTTI is used to find type of the object at runtime, and we are dealing with polymorphic object actually. We can actually use this method for determining type of a normal case, but that you never need. Like for example, int I, you won't like to find out the type of I ever in your class, because you know that is always going to be int and cannot be anything else. But anyway, you can use it if you wish, and there are some cases where you need, and we will talk about a case. Okay. But then RTTI is a heavy duty tool. In older compilers which I used to work at, I need to find out how to enable RTTI, and unless I do that, I cannot execute anything related to RTTI in C++. In the current compiler that I am using on my Apple Mac machine, Xcode, it does not demand me to do that, but I do not really know how they do it. It depends on the type of compilers that you use. When I used to use an earlier Microsoft Visual C++ compiler, well, I have to do it, so enable it. So, it is quite possible that in your own case you have a compiler which does not offer RTTI by default, and the compiler is doing it is doing just right in my opinion, because RTTI is a heavy duty tool and most of the programs do not really need it. So, what is the point in doing it? Okay. Because RTTI demands construction of first thing virtual table, and second keeping something called a type info object associated with every class that you have and that comes under the purview of RTTI. So, those additional burdens you do not want to have, so you may not go for it. So, that is the reason why compilers do not keep it on by default. So, you need to turn it on. Okay. Okay. But RTTI can do a few things which even virtual functions cannot, and we will see an example where RTTI makes a lot of sense. Okay. Now, there are some programs we are dealing with web and other things where there is a lot of additional delay due to that network latency, where having an additional RTTI and all that will not make much of a difference in the execution of a program. In fact, it is almost insignificant. So, in that case using RTTI is a good option. Okay. Virtual functions and a polymorphic object. Okay. We have already seen virtual functions can address polymorphic object needs very easily, and we have let us take a case where you have an item called news item. Now, is kind of a system where the user is having a lot of news items being displayed on the screen. The headings are displayed. Okay. Somebody looted somebody and these that is displayed on the screen, and if the user wants more information about it, will go and click that news item to get more detailed information about it, or right click on that news item to get it printed, or so on and so forth. So, there are, or store that news item somewhere in the disk, or send that news item to a friend of his or something. So, there are some right click options also available. We are talking about a typical case where we need RTTI here. Okay. We will begin with a case of printing. Now, assume that the news item that is coming on the screen are of two different types. One is called text, the other is non-text. Okay. The text type is something that you can print, and non-text is something that you cannot. So, whenever a news item starts flashing on the screen, I press right click. The requirement is that if the item is text, printing should be enabled. If the item is non-text, the printing should be disabled. Now, how will I provide that? Okay. So, what I do is, okay, This is what I need. Okay. So, the problem is that I can't have print virtual function in the news item class, because not all news items can be printed, only the part of it, the other news item can be printed. Okay. The text news items can be printed. So, in news is this, text news is this, non-text news is this. If I define print as a virtual function here, it is inherited by both. I do not want that, I only want print to be part of this text class. Okay. But if I keep this virtual or non-virtual, whatever, print here, I will not have that thing in the news item class. Now, that is my problem, because if I use a pointer here and there is no virtual function defined inside this class, I cannot call, I cannot use that thing normally. So, what should I do? Okay. In fact, one very simple solution, remember something that I have talked about before, I can always convert a base class pointer into a derived class pointer. If I cast that pointer into this pointer, I can have this virtual function. So, if I can cast this thing into this, my problem is solved. Okay. So, let me do that. Okay. What I will be doing, but that, remember that casting, okay, I can't just blindly do it. Not all news items are text. I will have to check what is the type of news item at runtime to decide. So, what I have is a statement of this type. R news is the news item that is coming in. So, what I do is I just say the type ID is an operator which is provided by RTTI, it returns something called type info object, basically a type. So, what does it do is R news item, the news item which is coming in, the type of it is the type, the same type as text. If so, I will cast, if it is not, I will not cast, is a simple solution. Okay. So, here is the skeleton of the program. I have, there is something called send, there is something called store and a destructor. Okay. So, these are simple parts of the function or the hierarchy. Okay. But now, in the text I have virtual void print. Okay. Remember, this is something which is very critical for us. Non-text will not have, okay, will not have print. Now, this is the function of our focus. We need to understand this is a right click function. Whenever, as I said, a user right clicks on a news item, some information is displayed based on the type of that item. Okay. So, the input is a reference to a news item. R news is a reference to news item, that is, and here is the choice that a user chooses to. Okay. And there are few other things, and we would, but then we can have send, store, but I cannot have print, because I do not really know whether the because if I provide print, will be true for some, will not be true for the other. Okay. So, I cannot provide. So, what should I do? I do this. This is very, very important now. I say, if the news item is the same as the text, and we will study about this in a little more detail soon, and now I will cast. The R news is casted into text reference. This is news reference, it is casted into text reference now, and then it is called printable news item, and then I will call printable news item dot print label, that thing, whatever. What does that mean? When a user right clicks on an item, the program checks this, and if the item is part of text, print is enabled and shown, if otherwise it is not shown. Okay. For example, if I have this main text T news and archic T news 1 will show me printable, otherwise it will not show. Now, let us try to understand about this type info object and the operator. Remember something that I have already talked about, RTTI will have to be enabled for this whatever we discussed in this particular module to work. Proper hierarchy should be provided with, because RTTI will make no sense if you do not have the proper hierarchy. Okay. RTTI has to work with dereferencing base class pointer or using a reference or a pointer to it. We have to have type info header to be added. Whenever we do that, type info header is to be added. Then and then the type info object for that polymorphic object can be referred to, and you get 3 important attributes of that particular additional object. Okay. We also have to link the type info library. There are 2 requirements, type info header as well as a type info library, and when you include both of them, you get some advantages. What are those? We will soon see. There are 3 operations that we can provide, which can enable us to do many things. So, whenever you apply a type ID operator, you can do something like this: type ID and object name will return a type info object associated with this object. Maybe this is employee E. So, what will it do? Will return a type info object associated with employee, so on. The type info object is stored in the first slot of V table. Okay. I will not be discussing about that, but as I said, you need to have the type info object associated with that class. You will have to store it somewhere, and compilers usually store that thing in the very virtual table where it stores virtual function. And in most cases, if you enable RTTI, V table is anyway generated even if you do not use virtual functions, because it is a very virtual table is used to store the this thing RTTI, this thing type info object. There are 3 operations possible. One is called function name, which returns the name of the object you are dealing with. The other one is overloaded operator double equal to. So, you can compare objects of 2 different names. If they are same, you will get the answer yes they are same. Not equal to is exactly opposite to it. It will check the inequality of 2 objects. For example, when I say that type ID R news double equal to type ID text, what I am doing is I am comparing the type info objects associated with R news and type info object associated with text class to be the same. If both type info objects are same, this returns true, otherwise it will return false. Okay. And this process happens at runtime. I can actually use type info object of non polymorphic case as well. Here is an academic example of doing it. I have class T defined, int and char, and there is a T class. Okay. So, I have defined all this. So, what is the type of I1? I will say type ID I1 dot name. Now, that is how you call this function name. So, when you call this function name, it will display the name of the object. Now, let me tell you that there is one catch here. In some cases, the compiler store a mangled name. Now, what that is, I am not going to discuss much, but it is a different name of the type. So, whenever you use this RTTI and do something like this, a mangled name is displayed, and how to get rid of that mangled name, there are some ways of doing it, and I will show you one way soon. Okay. So, if this does not display int and char and something else, it will display I or C or something, understand that is a mangled name, okay, and it is a mangled name or some strange string, and most likely it is a mangled name. Okay. So, if you want to convert those mangled names back into the actual name, you need to do something, okay, but otherwise this is just fine. So, it will display int. So, and this is the use of the other operator double equal to type ID I1 is the same as type ID I2, the type ID I1 is not the same as type ID C1, and so on, and type ID TSC dot name. Now, here it behaves so decently and it will display I1 type is int, I1 and I2 have the same type, I1 C1 aren't of the same type, object T SC is of type T underscore class, great. But if it is mangled, you won't get such names. So, one of the example that I am showing next uses a typical macro, okay, and I am using it. I am defining a typical macro called type name, which is, and I am not going to describe what is this, but is basically using a type ID name, applying 3 arguments as all zeros. Basically, this is going to demangle the name, okay, that I am going to display. So, instead of I, it will print int and so on and so forth. So, instead of type ID x dot name, I am using type ID name, that is the only thing. Now, what I am doing is, I am defining a shape plus, okay, object and a pointer, a circle and a square. Now, I am pointing P shape to all 3 of them one after the other and display what is their type, and I am just using type name. So, I will get their names of shape, circle and square as it is so. Okay. So, this is the other example of how you can use this type ID. Okay. Applying type ID can be done in 2 different ways. You can apply that thing to a class or an object. In either of the cases, we will return the type info object associated with the class. Please understand, there is a single type info object associated with a class, which is shared by all objects. Okay. So, one class is a single type info object shared by all objects. Okay. Comparing types need comparison of type info objects. Okay. Now, the point is only when you, like for example, casting a news item pointer into a text pointer is good only when the news pointer is actually pointing to a text class. Now, that can be achieved using this type ID, and that is the power of it. And this is known as downcasting, casting a pointer to a base class pointer to a derived class pointer, okay, is called a downcasting process, and this process downcasting is safe only when the base class pointer is actually pointing to a derived class object and not otherwise. And I have already talked about this library user and the designer issue in the previous modules, which is equally true here. In some cases where a library user has defined a hierarchy and I will have to use it, I cannot extend it, or I can extend, but I will, whenever I am running, I will have to find out what object my pointer is pointing to and take action accordingly. I will have to use RTTI, okay, and some specific action additionally to be taken, I can use RTTI. Okay. Some of us extend the given hierarchy, provide additional functions from our type. Some others would like to add, for example, an additional dimension to my 2-dimensional graphics library. Somebody would also like to add a few additional functions like draw, shrink, fill color, compress and so on and so forth. Why the RTTI is needed? Here are some examples. Library designer will design a hierarchy with whatever best knowledge it has, but then when the library is put to use, maybe used in a very different context, we will have to design it in a fashion which is most flexible and can be applied to all cases that we are dealing with. Here are some examples given. Okay. One typical example is known as a twin. In video and game programming, you have 2 different type of twins. One is called a motion twin. A motion twin is where you just specify that an item is here, at the end of it the item will be here. So, there are 2 points that you specify, and when you provide motion twin, the item is actually shown moving from this place to this place. And the other thing is called shape twin. You provide a square here and here is a rectangle, and now you say that the square is converted into rectangle. Now, that will be done gradually. Okay. So, intermediary images are generated. So, that process is known as shape twin. Now, both of these twins are used in practice. Now, that kind of a thing is to be added, then I will have to use the basic functions, basic shapes provided by the library designer and extend that thing in my own code. Okay. So, those requirements are very, very critical. I need to find out when somebody wants shape in, for example, I would like to find out what it actually is converting from and what it is converting to, and then take an action. Okay. So, such demands RTTI to be used at run time, okay, and that is the reason why in such cases RTTI makes a lot of sense. And all like virtual functions, non-virtual functions, pure virtual functions, RTTI, everything will have to be used with caution, and whenever there is a need you should use it. And I have shown a case where you really need an RTTI. For example, downcasting that we have seen, we need RTTI, we cannot work without RTTI. And there are a few other usages which RTTI interestingly can also be used with templates. We have already seen templates in module number 16 and 17. When we use templates, we write a typeless code. We are dealing with generic type like e-type and type, and that is what we have seen in module number 16 and 17. We do not really know what type it is, but sometimes we would like to provide some validations based on the type. We need to do it. Okay. For example, a stack e-type case, push and pop is generic, I do not need any problem. I do not have any problem of that code which is generic, but then I would like to provide some specific validations if e-type is int or char or something. How will I do it? I will have to add the type specific code in the middle, and I can use RTTI. I will just say that if type is this, then I will do this, if type is that, then I will do it. Okay, I will provide additional modifications. So, even in templates you can provide type specific coding using RTTI. So, that is possible. Here is another example. Suppose if there is a network case and somebody is looking at the packets passing through and figuring out what's wrong with it. So, it is a normal system that I already have which captures some information from packet and displays that thing. So, that normally is fine, but then in a specific case I have that source code of that thing, but I like to hack into that code and I will get more information about the packets, because it is a serious case, it seems to be an attack going on. So, I will have to hack into that system, figuring out more about that packet. What I will do it, I will write an RTTI part in the middle, see what kind of packet it is, and based on that type of packet will display more information. So, I will have to do it in an ad hoc manner. RTTI can be a very, very handy help. Okay. So, with that our discussion on RTTI, the first part on discussion of runtime type information is done. What we have seen in this module, RTTI or runtime type information is a system which runs at runtime and will help you determining the type of a polymorphic object. A polymorphic object is something which is part of a hierarchy pointed to by a base class pointer, and you can determine the type of it using the RTTI. RTTI provides the system which implements RTTI is usually optional. So, you will have to enable RTTI for working on programs which I am showing right now. So, and that is fine too, because most of the cases the programmers do not need to find out the types of polymorphic objects at runtime. When you need, you will have to enable RTTI and do it. Okay. In some latest compilers you do not need to do it, but it is just fine. RTTI uses a simple operator called type ID. It is an operator which when you apply to it will returns back an object called type info object. A type info object is constructed when RTTI is enabled. So, a type info object is constructed for every class. Okay. Whenever RTTI is enabled, it constructed for every class, and usually it is stored in the first slot of the virtual table. So, usually when that happens, RTTI is enabled, our V table is anyway created even if you have not defined any virtual function. So, that is the overhead that you will have. And the second thing is that RTTI happens at runtime, and that adds runtime overhead and slows down the operation as well. But the advantage is that will provide you determining the type of object at runtime. We have seen an example of news item whenever you use a news item which can be inherited into two different types, text and non-text, and would like to associate an option like print to the text type of an item, you can use RTTI to determine whether the news item is actually a text item. And if it is a text item, you can always pick it up and provide print, otherwise not. So, we have seen that code, okay, and that process is known as downcasting. Downcasting is considered to be a very dangerous process, but in this case that dangerous process becomes safe, because you do it, you just check type ID of both the items to be very sure that it is text, and then you will allow printing, and not otherwise you playing very safe. So, this runtime type information is going to help you in getting this downcasting in a safe manner. We have also seen that RTTI is also useful for templates, and is also used for doing some ad hoc addition to the system for a typical system level job. Whenever there is a typical demand, you need to hack into that code and do something with it. RTTI can be very, very handy. Okay. With that note, let us conclude this module. In the next module, we will see how you can apply RTTI using one more way of casting. Okay, that is called dynamic casting. There are 4 different types of casting operators headed by ANSYS C++ committee. We will be talking about it. That happened in 98. Okay. So long, but it still is, they are considered to be new operators, and these operators are going to provide, one of them is going to provide us serious runtime abilities called dynamic cast. We will be talking about that in the next module. With that note, thank you all friends, we conclude now.